first step in building a DC fast charger is the enclosure. This first step also gives us our first ergonomic challenge. We have to lift a large enclosure and put it on a stand to begin the assembly. Originally launched using a 2-person lift assist to place and orient the enclosure at the beginning of the line. Tritium has since invested in powered lift assists to lift and orient the enclosure at the beginning of the line with the least operator involvement. These lift assists have allowed us to ensure the process is as safe as possible while also being able to utilize the second person to perform other tasks. Another ergonomic and efficiency challenge was based around the basics of how we build the chargers. When we launched this factory in August of 2022, we brought all of the original processes developed in Australia. As we matured as a factory, we began improving our processes. One of the first we improved was our method of securing fasteners. Originally, we would hand start a fastener, change to an electric driver to begin securing the fastener, use a torque wrench to secure to the required torque, and then apply a paint mark to the fastener, validating that all steps were taken. There were several inefficiencies in this process. The first is how many different tools the operator had to use for each fastener. To secure one fastener, they may have to swap tools up to 4 different times. In addition, due to the complexity of the build, an operator may have upwards of 7 or 8 different torque wrenches available at a station they may need to use, and then they need to make sure that they were using the correct tool on the correct fastener. The first solution we decided to go to was using DC torque tools. We knew utilizing these tools would allow us to reduce to one tool for starting, driving, and securing a fastener. The next challenge was how do we control the torque being used at each fastener. We accomplished this by utilizing a bit tray to control the torque schedule. We still had the opportunity to use the wrong socket on the wrong fastener. The integration of a manufacturing execution system, or MES, allowed us to solve this issue. We talked to several different tool vendors and several MES companies, and in the end we decided to partner with Ingersoll Rand and Pico MES. This was due to several factors, but the main factor was the close working relationship that IR and Pico have together. This served to be crucial in the development of our system and the speed of our implementation. Another improvement we made was on our leak testing system. Our chargers have a liquid cooling system to ensure that we can keep all of the electronics cooled during the charging session, so it is very important that the system is free of any leaks. The initial process we launched at this factory included several gauges and levers that we had to manually turn on and off and record the readings to ensure that we did not lose any pressure during the test. We now have an automated test with a PLC to ensure that we maintain tight controls with the testing, as well as ensuring that no charger can get coolant added when there is a leak present. An additional benefit from the automation of this test is that there is very little operator involvement, so it allows the operator to perform additional tasks while the leak test is being performed. To ensure that we are making subassemblies correctly, we are implementing subassembly testing throughout our production line. We can test simple things such as proper wiring to more advanced things such as functional tests or even firmware calibration. These checks allow the technician to know they are doing an excellent job with the quality, along with shortening the post-production testing done at EOL testing. After completing the assembly of a charger, we put 100% of our product through our end-of-line test process. This end-of-line test process consists of 2 parts. The first is where we test the safety circuits, upload firmware and software, along with any customer-specific configurations. Once this stage is completed, it proceeds to stage 2, where we do several functional checks. Some of these checks go through the safety system to ensure they operate properly during a charge, and other tests actually put the unit through stress tests, such as a 45-minute full power charge. One of the final steps our chargers take is to get the vinyl added to the front and back of the unit. If selected, the charger can either get a Tritium standard graphic, as shown here, or a custom vinyl. Our large format vinyl printers are capable of producing any custom design on site. These printers utilize UV stable ink along with post-processing laminating to ensure the longevity of the exterior appearance of the charger. Our future plans include expanding our production over a second shift. We are also planning to add additional lines as we launch new products. To be able to support the expansion of our assembly lines, we will also be expanding our warehouse by another 40,000 square feet to be able to support producing 30,000 units a year.